Now let's try a couple more kinds of plastic. This is a large shower bin. My understanding that this is HIPS, high impact polystyrene. Probably you're familiar with this. It's from Schaller. And we're going to do 1500 milliliters per second, 5% power, 50 kilohertz frequency. And we are doing a crosshatch. This is also going to be the American flag. Good enough. All right. Let's give it a mark. Didn't see too much on that first pass, did we? You can definitely see the outline. So our new settings are going to be 1000 millimeters per second, 10% power, and 40 kilohertz frequency. Our hatch settings are going to be exactly the same as before. And let's go. That's much more visible. It's not really focusing. There's a dark mark. And this could just be because it's a red color. A little bit different than black. So I ended up marking this quite a few times, and anytime I increased the power, I ended up with too much of a raised bump, and it looked a little bit burnt. So basically keep the power somewhere less than 10% and keep your speed over 1000. If you want the darker mark that we did second, keep the speed a little bit lower and the frequency a little bit lower and the power a little bit higher, around 10%. But those are the results we got, and I'm pretty happy with them. You can see the variation in the marks in this picture. Let's move on to PLA. This is a piece of 3D printed PLA. It's just got a bunch of holes in it that I use to hold ER20 collets. Let's see if we can put it right there. All right, let's do it. That looks like absolutely nothing. I don't see anything at all. I think PLA is actually corn based, and I believe organic materials don't mark with a fiber laser very well. You kind of need CO2, so that's okay. Maybe it's not going to mark. Let's, just for fun, try it with a 100%. No, let's not do that. Let's do 70% power. We're going to use the same settings for everything. See if we can bring it right just a little bit. It shows up well. It doesn't diffuse like the Delrin did. Well, you can hear that. And it did mark. Interesting. It's a gray mark. So the increase in power helped. I'm assuming hatch settings aren't going to be a big deal here. So let's leave our speed. Let's bring the speed down a little bit. Let's cut it in half from 1000 to 500. Let's leave our power at 70. Let's, for the moment, leave our frequency at, let's just do frequency of 50, power of 50, and let's see. I'm going to do it over this one because I didn't see anything mark on the first try. It looks maybe a little bit lighter than the first mark. I don't know if that's showing up at all. You can sort of see that. All right, let's bump it up. Let's go crazy. Let's drop the speed down. So for our pen 1, I'm going to make the speed 1000 millimeters per second. We're going to leave it at 100% power this time. For pen 0, I'm going to take it all the way down to 200 millimeters per second, and let's do, where do we have space? Let's do that. All right, let's give it a shot. This looks terrible. That's probably the worst one yet, other than the one that didn't show up. I think the power is too high. It looks like we melted something. So I'm going to say I failed at marking PLA. The best result was around 70% power and 1,000 millimeters per second, but ultimately I really couldn't see much of the mark there, and if I increased the power or slowed down the speed, I would just end up melting the PLA, and if I reduced the power and increased the speed, I wouldn't really see anything at all. So maybe somebody has better settings out there. If you do, please share them with me. If you don't, no big deal. Maybe these can't be marked. This is a piece of clear acrylic. I'm going to try to mark it, but I don't expect to have success. I suspect this is more of a CO2 application. So I'm going to use settings of, this is going to be a dragon mark, and it's a vector file. So we're going to use a crosshatch at 45 degrees of 0.05 line spacing. Going to be this pattern. The total dragon is about 25 millimeters tall. And we're going to use pen 0, and it's going to be a starting point of 1,000 millimeters per second, 10% power, and 40 kilohertz frequency. So I peeled back the film. It's a fresh piece. The film is still on the other side. I don't know if anything at all is going to happen. What we're going to do is quick and just do one pass. So if we light it up, it's going to show up right there. Stop and go. I see nothing at all. Nothing on the back, nothing on the front. Interesting. Just for fun, let's leave everything the same except for the power, and let's up that to 90%. Light it up again, same place. And let's go. Well, I heard something that time, but it burnt through to, well, there's what happens with that. You burn through right to your base. So that gives you a sense of how much the focal point matters. This is about a 5 millimeter thick piece of plastic. So you can still mark a pretty good mark if you're off by that much. And this is the backer. Everything I read said a fiber laser can't mark clear acrylic, but it can mark colored acrylic if you keep the speed relatively high and the power low, just like any other plastic. So, lesson learned. I've got a little dragon marked on my base now, that's fine. So next let's move on to polycarbonate. And just for fun, this is a piece of scratched up polycarbonate. I'm going to try to be marginally more intelligent this time and throw something underneath it so I don't put a dragon on my surface there. Let's light our dragon, there it is. This seems relatively flat. And let's go. So initially when I marked this, I didn't expect it to work based on my results with the clear acrylic, but as you can see it's marking, I think it's 90% power. Now that's interesting. That marked very dark. It's extremely raised right there in the center. I guess there's a big difference between polycarbonate and acrylic. Let's do it again. So based on the number of dragons I have now marked on this piece of polycarbonate, you can kind of guess that I went down the rabbit hole a little bit in terms of playing with settings. I would either have a mark that was too light and then too dark right at the center of the tail, or there was a little bit of an artifact or two in there. I could see some lines, or it was just way too dark and the polycarbonate bubbled up. I'm not sure if I struggled with this so much because it was a clear polycarbonate, or if that's polycarbonate in general, or if maybe a colored polycarbonate would have worked better. The settings that I ended up with that worked pretty well are the ones I'm running right now. 1,000 millimeters per second speed, 20% power, 30 kilohertz frequency, hatch of 0.01, and an angle on that hatch of 0 and 90, although I'm not sure the angle matters that much. You can see from all of these marks that I had a ton of variation with minor changes in things like frequency, power, speed. It just I couldn't really find a sweet spot. I couldn't really find something that would consistently work other than these settings I just gave you. So I'm going to jump ahead a little bit. And let's mark it. Well, it looks better. So that more or less sums up my experience marking different plastics: high impact polystyrene, PLA, acrylic, and polycarbonate. I had some success with the polystyrene and with the polycarbonate, although it was a little bit frustrating to mark that, and as you can see by the number of dragons again. But the PLA I completely failed with, and the acrylic I think I failed with it because it was clear. So anybody has any feedback for me on any of these materials, I'd appreciate it.